Every episode so far, the AI has lived on a screen. It reads, it sees, it talks, but it can't touch anything. This episode, it gets a body. We're talking about robots and about what NVIDIA calls physical AI, artificial intelligence that acts in the real world. It might be the most important frontier of all, and NVIDIA has open-sourced the brain that runs it. If AI is going to fold your laundry, stock a warehouse, or care for the elderly, it starts here. First, why is this so much harder than everything we've seen? Because the real world doesn't cooperate. It's messy and unpredictable. No two situations are ever exactly the same. It happens in real time. A robot can't pause to think while it's pouring a cup of coffee. Its actions are irreversible. Drop the cup and it's broken. There's no undo. And it has to control a physical body with balance and force and timing. Chatting is easy. Doing is hard. So what does a robot's brain actually look like? It's a new kind of model called a VLA for vision language action. It ties three things into one. Vision, so it can see the scene in front of it. Language, so it can understand a command like pick up the red block in plain words. And action, the crucial part, it outputs the actual motor commands to move the robot's joints and hands. See, understand, act in a continuous loop. That's the leap from an AI that describes the world to one that changes it. And here it is, open for anyone. Isaac GR00T. The name stands for Generalist Robot 00 Technology, and it was the world's first open foundation model for humanoid robots. It's a generalist brain. You download it, then adapt it to your particular robot and tasks, rather than building intelligence from scratch. Crucially, it's cross-embodiment, meaning the same brain can drive different robot bodies. Tens of thousands of downloads a month and a fast-growing community are building on it right now. But a robot brain is only as good as what it's trained on, and that's the hardest part of all. To learn a skill, a robot needs a mountain of examples, and collecting them with real robots is painfully slow and expensive. NVIDIA's answer is a clever pyramid of data. A little real robot data at the top. A lot of human video in the middle. The robot learns by watching people. And at the base, a near infinite supply of synthetic data generated in simulation. You train the robot in a virtual world millions of times, then deploy it into the real one. And this is why NVIDIA is betting so heavily on physical AI. For decades, robots were confined to cages on assembly lines, doing one bolted-down task. A general-purpose robot brain changes that. Robots that can adapt, learn new tasks, and work alongside us in warehouses, factories, hospitals, and eventually homes. It's a shift that could reshape the economy, and by open-sourcing the brain, the simulation, and even the chips to run it, NVIDIA is trying to power the entire wave. So physical AI is where the digital finally meets the physical GR00T, the open brain, learning skills and simulation before it ever touches the real world. And that idea, training AI inside a simulated reality, is so powerful it deserves its own episode. Because to teach a robot, first you have to build it a world. Next time, world models. See you there.